Hello and welcome to Geology and Geotechnical Engineering's presentation. Uh, Today I'm going to discuss the geological time scale and especially the lower part of this scale, which is the Pre-Cambrian eons, starting with the Hadean, the Archean and the Proterozoic, where our planet Earth took its shape during these three major super eons of our planet Earth beginning history. Well, the geological time scale is simply a table contains evidence and catastrophic events happens to the Earth throughout its history from the time of the planet's birth until our recent time. The geology as a science started at the beginning of the European Renaissance, and at that time the secularity won against the rule of the clergy or the fundamentalism in the European society. The first person who contributed to establish the geological timescale is the Danish Nicholas Steno. In 1669, he argued in his book De Solido that rock layers were laid down in succession, and that each succession represents a slice of time of the Earth history. And this slice of time, he called it the strata or the layers. And he suggested that the newer layer precipitated above the oldest rock layers. Giovanni Artiano in 1716 classified rocks from the Alps into four groups. The first group, the oldest one, he called them the primary, and the secondary and the tertiary, and then the recent rocks, he called them the quaternary rocks. James Houghton, 1723, established the law of uniform etherealism, which is the fundamental law in science of geology, proposed that the present evidence can interpret the past evidence happens at the surface of the Earth. And Abraham Gottlob Werner in 1749, he suggested a theory about the stratification of the Earth's crust. The great philosopher William Whewell, 1794, wrote, "The geologic past may have consist of epochs of paroxysmals and catastrophic action, interposed between periods of comparative tranquility." This idea and or theory gave us a great contribution to divide the times in the geological time scale. William Smith, he used fossils to date the strata suggested by Steno, and he noticed also that a special group of fossils can be dominating the oceans of the Earth in a distinct time, and then this type of fossils can disappear, and another species of same family of the fossils can continue living, and the other simply disappear. These help them to divide the geological timescale and make a parallel geological timescale that specialized in fossils and fossils divisions and dominations in the oceans of the Earth from the time of the birth of the planet until our recent time. The other two scientists that contributed in development of the geological timescale are the Margaret Todd and Frederick Soddy. In 1913, they suggested to use the isotopes for dating the precise ages of the geological materials. And I'm going to make a special presentation for the isotopes and techniques that you've been used to date materials, organic and the non-organic materials. There are two organizations that takes care of the layers and strata and stratigraphy of the Earth's crust. The first one called the GSSP, established in 1977, which is the Global Boundary Stratotype Section and Points, and the second one is the ICS, established in 2015, which is the International Commission of Stratigraphy. Both organizations are taking care of the stratigraphy of the Earth crust. This is the geological time table or time scale, which is divided into two dimensions. The first dimension in the parallel to the x-axis, which is the events and the catastrophes dated in Latinisc words. Then in the X dimension, we have the Latin words such as the eon, which is all of the table is divided into two eons. The first one is the Pre-Cambrian or Super Eon, which composed of the a great period of time of the Earth history from 4.6 billion years until about 538 million years ago. So these three eons, the Earth has been developed from the birth to a planet goes around a central sun, which is our sun. The rest of the eon calls the Phanerozoic, which is divided into three major era, and these era are divided in periods, and the periods are also divided into epochs, and the epochs are divided into ages, and the ages are divided into times and subtimes and so on. In the X dimension, it is simply a division of time according to the events and catastrophe happens to the Earth surface. Just to remember that the oldest layers in the geological time scale are we can find at the bottom of the table, and the newer layer and events we can find them at the top of the geological time. To make a comparative understanding to the geological time table and our very simple quartz watch, which in the quartz watch we can divide the time into years, months, days, hours, minutes, seconds, milliseconds, and microseconds. The same division we have made it here, which is the Eon, era, period, epoch, ages, times, and subtimes, and so on. This is just to make understanding, a simple understanding to the geological time divisions in the geological time scale. In this presentation, I'm going to speak minorly about the super Pre-Cambrian Eon, which are the three first eon in the Earth history. The Hadean, which means in Latin hill, the Archean, which is the apparent of life form happened there, and the Proterozoic, where the life form are apparent at that period of the Earth history. Where in the following I'm going to discuss just these three eons and find out what happened or how the planet Earth started to be a planet and contain a life form which is unique in our universe. It is quite important to realize that the geological time scale should be read from the bottom to the top and not in the reverse order. The Pre-Cambrian super eon has been divided into three major eons, which are the Hadean, the Archean, and the Proterozoic. And regarding the Pre-Cambrian, it varies around 4 billion years to make the in this period of time the Earth was ready to receive the life at the surface of the Earth. So the Pre-Cambrian super eon varied or extends around 4,092 million years, and this period of time is the lower part of this super eon is the Hadean Eon, which extends 496 million years and divided into four eras. The oldest part of the Hadean called the Hadean, which is the cryptic basin era, and the Paleo Hadean, which is the old part of the era, all part of the Hadean, and the Nectarian era, which is the middle part of the Eon Hadean, and the New Hadean, which is the upper part of the Eon Hadean or the late Hadean. And the evidence has been registered in this part of the of time of the Earth history is that the formation of the solar system has been happened in this period of time, and due to the explosion of the huge high mass star and the nebula and the creation of the solar system, 20 planets or rocks, major gathering rocks, has been created very near to the sun domain, and these 20 planets collides together to make just 4 of them being survived in a huge bolt of fire. And this energy or fire comes from the collision forces of the gravitational attraction between the asteroid and meteoroids together. The gathering together, this process make the energy high enough to dissolve these comets in one giant bolt of fire. The period after that, the Earth began to cool down, but it was a very short time. Another planets impact the Earth, and it's thought that this planet become the moon, our moon, and orbiting the planet Earth. And the episode after that is that the Jupiter and Saturn, which were the huge gas planets and acts as a vacuum for many residual parts of the nebula, or of the explosion of the nebula, they could have a gravitational forces to push many asteroids made by hydrogen and oxygen, which is the ice, water ice comets, and push them beyond the asteroid belt towards the new born or new planets, the terrestrial planets. So the Earth got a huge portion of these comets, and these comets began to compose the ocean at the surface of the Earth. The evidence or the catastrophe or the process that happened after that, in fact, is that the Earth were still active volcanic activities, many volcanic activities at the surface of the Earth, and the result was the dissolved rocks, the iron content of the dissolved rocks began to move towards the center of the Earth, and this made the Earth having a very hot and dense and very strong stable core. And this core was hot enough to make the surrounding materials, the magma materials or the solid rock materials, move around it. And this movement produced, of course, the Earth magnetic field. The Earth magnetic field was very important to the planet Earth because it began to protect itself against the sunstorms, and the sunstorm, when they reached the surface of the Earth, the volcanic eruptions began to be active again. By these events, the sun storms prevented to reach the Earth, and the Earth began to cooling down more and more. So the evidence of the life began to appear at the surface of the Earth at the period after that in the Meso-Hadean or the Nectarian basin, and it has been registered that from the isotopes of carbon that the evidence of the life began to appear at that time of at that era of the Eon Hadean. Regarding the carbon isotopes, the carbon itself as a chemical element has 15 isotopes and starts from the carbon 8 to carbon 22. The most stable carbon is the carbon 12 and carbon 14 and carbon 13. The carbon 14 used as dating for the organic matter, and the carbon 14 in fact has a half life of 5,730 years. And there are also some isotopes of carbon which are the having a life, a half-life of between 20 minutes to 200 milliseconds. That is a very unstable isotopes of carbon. Regarding the isotopes, I'm going to prepare a special presentation to understand, to make the audience understand the mechanisms we use to measure the age of the materials using the isotopes of the chemical, different chemical elements. So the Earth in this period of time, after this period of time, began to have a stability, and some types of photosynthesis evidence has been registered in this period of time, and the atmosphere of the Earth were dominated or was dominated by the gases like nitrogen, carbon dioxide, and methane. And the Earth is totally not was not ready to receive any type of life development in this period of time. The new Hadean or the early Cambrian varies around 150 million years. The Archean is the eon that is known as the appearance of the life at the surface of the Earth. The Archean extended 1,200 million years and has been divided into 4 major eras, and these eras has been also separated due to the catastrophes and events happened at the surface of the Earth. The EU era, which is the oldest part or the lower part of the Eon Archean, dominated by the appearance of the simple single cell of life, which is the bacteria, and cyanobacteria, archaea, and some type of microfossils, and self-replicating RNA molecules. At the period after that, which is the Paleo Archean, the evidence of the appearance of oxygen has been registered at the rocks dated back to this period of time. The Paleo Archean extended 400 million years, and during this period of time, a huge number of bacteria and one cell bacterial organism dominated this era. The appearance of stromatolites, which was which could convert the carbon dioxide into oxygen, dissolve oxygen in the water, and this by using the process of the photosynthesis. Therefore, it's believed that they were a type of plants appear at the shelf areas of the oceans at that time of history of Earth history. So the appearance of the stromatolites were very important to produce the oxygen dissolved oxygen into the oceans of the Earth at that period of time. So the stabilization of stable part of the continental crust also happened in this period of time. The new Archean extends around 400 million years. The Proterozoic Eon is known that it is the eon where the earlier life form dominated the oceans of the Earth. The Proterozoic extended to 2,262 million years, and it has been divided according to the events and the catastrophes happened at that time to three major eras: the Paleo Proterozoic, the lower part of the Proterozoic Eon, and the Mesoproterozoic, and also the new Proterozoic, which is the upper part of the Proterozoic Eon. These eras has been also divided according to the events happened at the surface of the Earth that changed the shape of the Earth, a general shape of the Earth. So the first period of the lower Paleo Proterozoics known by the Hadean. In the Hadean period, the oxygen that has been made in the Archean, in the waters, in the ocean's water, has been banded in this period, which means that the rock formation, especially the iron rock formation, because the oceans was rich of irons, and the irons composition of the water used the produced oxygen from the bacterial life to be precipitated and make rock formation rich of iron, just like the hematite rocks and magnetite rocks, and also siderite rocks, which is a composition between carbon and iron. In the Archean period, glacialization dominated the planet Earth. And this glaciation varied or extended around 200 million years. And in this period of time, the bacterial life and organic life were still active and was still active to produce oxygen and dissolve it in the ocean's water, and prevented the rock formation beneath the glacial ice. And that is a very major events happen to the history within the history of the planet Earth that make the atmosphere of the Earth rich of oxygen and dominated by oxygen, and the ozone layer began to also be dominated at the upper part of the Earth atmosphere. And that happened in a period of time of the middle of the Paleo Proterozoic, called the Oro-Sirian period. And the period after that, which is the Statherians period, complex single-cell life forms with nuclei dominated the oceans of the Earth. And this period extended 250 million years. In the Calamanian, in this period of time, appearance and expanse of the drylands being also registered, and an orogeny, which means that the tectonic life, tectonic cover of the tectonic plates cover of the surface of the Earth began to move and rise up to make some to make some continents of the Earth. And the first part that rised up and exposed as a continent registered to be in the North Australian areas. In the Ectacean, the green algae dominated the oceans of the Earth, and in Estonian, the metamorphic rocks appeared to be dominated the surface of the Earth. That is a sign that the rock circulation began to work at this period of time, which is the explosion of the land, the continents, make the atmospheric weathering processes activity high, and the results of the weathering processes being transported to in a process of the erosion may happen to these sediments to the sea, and then from the sea to the beneath of the subduction zones, and come up again as igneous rocks. And this circulation happened, of course, and the lands began to also have a extension at the surface of the Earth. In the Tonian, appearance of dianoflagellates, which is a type of single-cell algae, appeared in this period of time, and this type of single-cell algae are important to measure the significant changes happen to the temperature and the chemical composition of the oceans at that time. The Earth's surface become entirely or nearly entirely frozen at the period called the Cryogenian. In this period of time, the Earth was a snow ball, and everything's been covered by glaciation again. And this period extended in around 280 million years. The period after that is the domination of the fossils, and the multi-cell animals dominated the oceans of the Earth. Now, for this is a presentation, I would like to come up with some conclusions. The planet Earth evolution to host life forms took around 4 billion years. It is probable that the terrestrial planets, which are the Mercury, Venus, Earth, Mars, got its chance to host water from the icy comet's bombardment, but just the planet Earth could protect its surface water from evaporation due to the size of the suitable size of its core and the strong magnetic field produced by the core of the Earth. Our searching for the exoplanet or the Earth twin planet that can host a habitable world failed so far. The discovered Earth-like planet shows up to be in a slow motion of evolution and remains in the middle part of the or the lower part of the super Cambrian Eon conditions, which is nearly the Hadean Eon. I would like to thank you for watching this presentation, and my name is Saba. I am engineer geologist, and my next presentation will continuously deal with the geological timescale and the Earth evolution during the Phanerozoic Eon, and especially the lower part of Phanerozoic, which is the Paleozoic era. Please like, share this presentation to your friend, and again, thanks again for watching this presentation, and take care.